Hello everyone, today we are going to see the qualitative inorganic analysis, which is also salt analysis. In this today's session, we are not going into deeper level of talking about each and every reactions, but we are going to cover what are the frequent questions asked, what are those important points. If you want the detailed analysis of detailed reactions of this chapter, I'll be attaching the notes in the description. Please go through it. But for now, whatever needed for the exam, we are just seeing that. Okay. But as I said, always you have to practice the question once you have completed the crash course. The concept is not enough. Solving the questions is equally important as you learn the concept. Okay, so without any further delay, let's get started. First of all, what is inorganic salt? It will consist of ions, right? Positive ions and negative ions, anions and cations. So if I'm taking any salt, let's say copper sulfate, magnesium oxide, sodium hydroxide, sodium chloride, potassium bromide, any salt, that will have two parts. One is anion part, another one is cation part. Here we are taking the anion part as a basic radical. Let's say copper sulfate, Cu2 plus is our basic radical, and the cation part is basic radical, and the anion part, that is OH minus or SO4 2 minus, those are our acid radicals. Okay, so what are the tests we can do to confirm what kind of radicals are present? That is what this chapter talking about. If you are taking the trends of questions asked about this chapter, you can see one or two questions will be definitely asked for JEE Advanced, and some mixed questions you can expect from this chapter. So let's see one by one what are the steps and what are the observations we do. Finally, we are going to solve around 10 to 12 questions in the end of the session to make your concept stronger. The first test is preliminary examination. It will cover the color or smell or solubility, texture of the salt. And then action of heat. I'm going to heat that given salt by dissolving it into mixing it into water or acid. I'm going to heat that up. What I'll observe, if that is carbonate is present, it decomposes to oxides plus CO2. Okay, they will give these clue points and ask you to find what is that salt. Okay, so carbonate is present, then it will decompose to oxides plus carbon dioxide. If nitrate is there, NO3 minus is there, it will give NO2 plus O2, and hydrated salts will lose the water. Okay, for example, if I am having copper sulfate pentahydrate, then upon heating, what will happen? Copper sulfate pentahydrate is blue in color, right? Upon heating, it will lose the color gradually. In the dehydrated state, it will become white in color. Okay, so hydrated salts always lose the water when we are heating it up. Okay, then dry heating test. Here it will lose the crystallization, of course, and then there will be a color change in anhydrous form to from the hydrated form to anhydrous form, and you can see the droplets on the test tube walls to indicate that the hydrated form is getting evaporated. Then the decomposition, carbonate salt is present. Let's say calcium carbonate is present. It will decompose as calcium oxide and carbon dioxide. How will you find whether that is carbon dioxide or not? You can do the lime water turns milky test. Okay, upon passing carbon dioxide to the lime water, it will turn the Lime water, which will be pale in color, right? It is not, it is colorless. Carbon dioxide turns it white or milky. So that indicates the presence of carbonate salt. The next one is, if I am taking ammonium chloride, it will release ammonia and HCl. How do you find that is ammonia? It will create a white fumes of ammonium chloride on rod. If you are introducing the HCl dipped rod to ammonia, it will create a white fumes. And also ammonia have the peculiar rotten smell. You can find it out easily. Then flame test, most important test. Salt analysis without flame test will not happen. Most important, you have to memorize the colors of these salts. First one is sodium. Sodium plus, that will give you yellow flame. Potassium, violet flame. And barium, very very important, apple green flame. Copper, as usual, blue to green flame. Then borax bead test. These are the tests asked in the previous year question papers as well. Borax bead test is used for the detection of metal ions. Heating the borax formula is Na2B4O7. It forms a bead with the metal oxide. Whatever the metal we are using, it will form a bead. For example, with copper, it will form a blue bead. And with chromium 3+, it will form a green bead. And Gopal 2+, it will form a deep blue bead. Okay. Depend on the metal present over there, the color of the bead will be formed. Okay. Then wet test is detection of the anions. Carbonate we already saw, which will produce carbon dioxide. If they are giving, upon heating it is producing carbon dioxide, means you can close your eyes and take the answer, that is carbonate. Then sulfate. This is the most frequently asked question. Sulfate test, for barium chloride also this still holds true. Barium chloride I am taking and dissolving it, treating it with H2SO4, it will form barium sulfate, which is white color precipitate, that is insoluble in HCl. Okay. And chloride test. Silver nitrate. Upon adding silver nitrate to chloride, it will form AgCl as a curdy white precipitate. Sometimes they will refer to as white and sometimes they will refer that as curdy white precipitate. White precipitate means that would be chloride ion present, that is yellowish precipitate, then that would be bromide ion. Okay. Then nitrate, brown ring test is there. Adding FeSO4, Fe there, that is in +2 oxidation state. Reminding you, FeSO4 and concentrated sulfuric acid we are adding on the sides of the test tube so that the brown ring will be formed. Brown ring test, it's for nitrate, not other nitride or nitrite, nothing. It's for nitrate. Okay, brown ring test. It is formed. Then we are going to talk about the wet test of basic radicals, cations. So group 1 radicals are lead 2+, silver plus, mercury 2+. We are adding dilute HCl. If that is white precipitate is formed, means group 1 ions are present. If there is no precipitate, we are moving on to the next step, that is group 2. Group 2, which will have copper 2+, bismuth 3+, cadmium 2+, and lead 2+. We are passing H2S gas in acidic medium, because for group 4 also we will be passing H2S gas. There we will maintain alkaline medium for group 4. Group 2 we are maintaining acidic medium. Each one of the word I am mentioning over here, which is really important, please note it down. This is the crisp crash course for salt analysis. We are maintaining acidic medium passing H2S gas, and the formation of precipitate is sulfides, CuS, PbS and cadmium S. Okay. Then the color of the sulfides, mostly the sulfides will be indicated by the black color, except the cadmium sulfide, that is yellow in color. Moving on to group 3. If both the group 1 and group 2 is not present, then we are moving to group 3. Reagent here we are going to add is aqueous ammonia or NH4OH, ammonium hydroxide, and ammonium chloride buffer. Here white precipitate for aluminium hydroxide. Sometimes they will refer to as gelatinous white precipitate. Jelly kind of substance will be, it's not purely jelly, but some kind of semi-solid kind of gelatinous white precipitate for aluminium 3+ ion, and red precipitate for iron, green for chromium. Each of these are forming hydroxides. Okay. Then group 4, here we have zinc, manganese, nickel, cobalt, all are in 2+ state. And the reagent, I told you, right, alkaline medium here we are using for passing H2S gas. The precipitate formed are zinc sulfide, buff color, that is manganese sulfide, black for nickel sulfide and cobalt sulfide. In the question itself, they will provide you H2S is passed in the alkaline medium or acidic medium. Sometimes they will provide in the presence of HCl, in the presence of NaOH. Mostly they won't give NaOH. They will maintain a slightly alkaline medium. So please be clear with group 4 and group 2. Then group 5. The reagent here we are using is ammonium carbonate. We already added ammonium chloride and ammonium hydroxide. Along with that, we are adding ammonium carbonate. White precipitate is formed for barium carbonate, strontium carbonate and calcium formate presence. Then finally we have group 6. We are adding the strong base, that is NaOH, and doing the Nessel's test. Nessel's test for ammonium ions. Okay, group 6 has Mg2+, sodium+, potassium+, and ammonium. So these are the 6 groups. The ions present in the groups are also important. Confirmatory test is also important. Then we are going to test which ion is present in that particular group. As I said, the group 6 ammonium, order of the ammonia gas from that you can find, are doing by the Nessel's reagent test, you can find it out. Ammonia is present. Then calcium, flame test will show brick red and white precipitate with ammonium oxalate. Copper, mostly copper will be indicated by the blue precipitate or blue flame, blue solution, like that. So blue precipitate with ammonium hydroxide and deep blue complex. This is important. Deep blue complex in excess of ammonium hydroxide. Okay. Then iron 2+ and 3+. Iron forms green precipitate with ammonium hydroxide, and Fe3+ is present, means then that will show brown precipitate with ammonium hydroxide. And the complex formation, that is with potassium thiocyanate with Fe3+, which will give you the red color precipitate. That is also a blood red, bright red color precipitate for Fe3+. Once again, I'm telling you each of these reactions. If you have any doubt in between, you can refer to that material also. Then we are moving on to this systematic analysis flowchart. First, what we have to do, preliminary test, then goes to anion test, then cation, and the confirmatory test. This is the order we have to follow for testing. And I'm giving you the common tricks and shortcuts to find it out which ion that can be. The color based ones are copper, most importantly. Blue green salts means copper, and yellow salts which will indicate iron 3+, chromates that will form white salts. In the white salt, which is aluminium, zinc, lead and manganese. Yellow salts for chromates and iron 3+. You can see the frequently asked questions are: lead with potassium iodide forms a yellow precipitate. Yellow precipitate is PbI2, and barium with sulfate, it is forming white precipitate of barium sulfate. And ammonium hydroxide with NaOH, it is releasing ammonia gas, which is pungent odor. And these complex formation of Prussian blue, that is a test for iron 3+, and nickel. Sometimes they will refer to as red precipitate, and also sometimes they will refer that as rosy red precipitate. Coincidentally, this is the color. What are the ink I'm using? That color is our rosy red precipitate for nickel. Dimethyl glyoxime, which is DMG. It is forming a caged or chelated structure with nickel. And aluminum ion test for aluminium 3+ is red lake formation. These three complexes are very, very important in case of examination point of view. So these are the important parts of salt analysis. Let's solve some questions. Let's say this question, which is asked in JEE Main: which of the following cations does not produce a precipitate with H2S in acidic medium? I told you they'll mention acidic medium. Acidic medium means which group? Group 2, right? So group 2, which of the salt are coming under group 2? Copper 2+, tin 2+, arsenic 3+, and Fe 2+. Which salts in group 2? Copper 2+, tin 2+, are forming copper sulfide and tin sulfide. In case of arsenic, As3+ belongs to group 5. So we are not taking it up. And again, it will get precipitated as sulfides. But what about Fe 2+? It will not precipitate with H2S in acidic medium. But in case of basic medium, it can form the precipitate. So they particularly mention that is acidic medium and does not produce any precipitate. So answer to this question is Fe 2+. Let's say this question, JEE Advanced question: a crystalline salt which is white in color, X dissolves in water to give neutral solution. Okay, on passing H2S gas through a solution of X, presence of dilute HCl, which means the acidic condition is maintained. No precipitate is formed. Group 2 also no precipitate formed. However, on passing H2S gas through the solution of X in the presence of ammonium hydroxide, which refers to as alkaline medium. Alkaline medium, a white precipitate is obtained. So it clearly mentioned that X must be group 4. The cation present in X is. So that is our question. So zinc 2 plus, lead 2 plus and copper 2 plus. So among these, which is group 4? Zinc 2 plus forms a white precipitate with H2S in alkaline medium to form zinc sulfide. So answer to this question is Zn 2 plus. And the next question, a colorless aqueous solution contains a cation and an anion. A solution gives a white precipitate with dilute HCl, which dissolves in hot water. The solution also gives a white precipitate with sodium hydroxide solution, which is soluble in sodium hydroxide, which means that after forming a precipitate, it started dissolving in it in the presence of excess sodium hydroxide. The anion gives a white precipitate with silver nitrate solution, which is soluble in dilute nitric acid. Identify the cation and anion. So first, white precipitate with dilute HCl, that is dissolving in hot water, which suggests the presence of lead ion, because lead chloride is sparingly soluble in cold water, but it dissolves in hot water. Then the second hint is that white precipitate with sodium hydroxide, which is soluble in excess of sodium hydroxide. So, and also the anion gives the white precipitate with silver nitrate. So which means lead is confirmed. What about the anion? It can be of chloride, bromide or iodide or acetate also. That is a possibility, which is forming a precipitate with silver nitrate. Since AgCl, silver chloride, forms a white precipitate which is soluble in nitric acid, the anion is most likely to be chlorides. So answer to this question, the salt is lead chloride. Let's solve this question. Which of the following anions will not give a precipitate with barium chloride? Will not give precipitate. Barium forms a white precipitate with sulfate, that we know very well in acidic conditions. And barium forms a precipitate with carbonate, it is barium carbonate. Phosphate is also formed, but these are dissolved in acids. But in case of nitrate, it does not precipitate with nitrates. Barium nitrate will not be formed in acidic medium. So answer to this question is nitrate. A white salt dissolves in water to give a clear solution. Passing H2S in acidic medium does not give any precipitate, but ammoniacal medium, a black precipitate is obtained. So it must be belongs to group 4. So H2S in ammoniacal medium gives black precipitate. It suggests that copper or nickel, which is of group 4, can be of present. Here copper is given in the option. So we can take the answer is copper 2 plus. Which of the following reagents will not distinguish between Al3 plus and zinc 2 plus? You can see ammonium hydroxide gives a white precipitate with both. Right, these are belongs to group 3, zinc and aluminium. So it will precipitate with both and dissolves also in excess of ammonium hydroxide. If I am taking sodium hydroxide, it also forms a precipitate with aluminium 3 plus and zinc 2 plus. But what about H2S in acidic medium and H2S in ammoniacal medium? We have to consider, will it form a precipitate or not? In ammoniacal medium, ZNS is forming but not with aluminium 3+. ZNS formed but not with Al 3+. But what about H2S in acid medium? Both the ions will not precipitate in acid medium. So answer to this question is option D. The next question, which of the following cations give a blue solution in the presence of excess of ammonium hydroxide? Blue solution, obviously, that is copper. Not only that, I told you from when we are reacting copper with ammonium hydroxide, it will form a deep blue complex, right? The complex is copper amine complex. It should be look like this. Which of the following gases is evolved when ammonium chloride is heated with sodium hydroxide? This reaction also we have seen. Ammonium chloride with sodium hydroxide, which will produce ammonia gas. What else you can expect? So ammonia gas, along with that sodium chloride will be formed and H2O. So answer to this question is NH3. Then which of the following will form colored complex with thiocyanate? Thiocyanate SCN minus, I told you, with Fe3+. That is a major distinguishing criteria for Fe2+ and 3+. With 3+, it will form blood red complex, isn't it? So answer to this question is Fe3+. Which cation forms a white precipitate with silver nitrate which is soluble in ammonium hydroxide? Once again, we saw that cloudy white precipitate with silver nitrate, that is none other than our AgCl, and by adding excess of ammonium hydroxide it will get dissolved. If they are giving yellow precipitate, then you have to go for bromide or iodide, and sulfate, carbonate, phosphates will not form any precipitates. So answer to this question, which is Cl minus. Which of the following will not produce a precipitate with sodium hydroxide in aqueous solution? Sodium hydroxide with aqueous solution. Which group that refers to? Aluminium, Fe3+ and manganese 2+ forms a hydroxides precipitate, right? These are belongs to group 3, and sodium does not form any precipitate with sodium hydroxide. Which of the following compounds will give a positive to chromyl chloride test? This is a MSQ type of question. KCl and NaCl, KBr and potassium dichromate is there. Here you can see chloride ions will give positive to chromyl chloride test. The formula of chromyl chloride is that O2Cl2. So both the answers are right. Then the last question, a cation M2+ forms a white precipitate with ammonium hydroxide which dissolves in excess of ammonium hydroxide. It also forms a white precipitate with sodium carbonate. The cation is. So formation of white precipitate. Formation of precipitate with ammonium hydroxide, it clearly indicates that should be from group 3, right? So zinc forms a white precipitate with ammonium hydroxide, and it will get dissolved by adding excess of ammonium hydroxide. But also it forms a precipitate of zinc carbonate with sodium carbonate. So I'm attaching the remaining questions, the detailed notes in the link. So please do check it out and practice more and more questions. Let me know what else chapter you want as a video.